So today's question is trapping rainwater. So we have given a non-negative integer representing an elevation map where the width of each bar is 1. So we have given an elevation map. We have given a input array of a height of each element. Means for this element the height is 0. For this element the height is 1. For this element height is 0. For this element height is 2. So like this we have given the heights. We have to find that how much rain we can store between these cubes or elements. Like we cannot store any water here. We can store 1 unit water here. We have given the width of 2 adjacent is 1. So we can store one water here, other one water here. Here we can store two water, one water here, one water here. So we have to return the total number of unit of water we can trap. So like this example is given. Let's explain how we will solve this. So like we have given this map. So here we can store 0 means we can not store any water because it does not have any left boundary. It has right boundary, but it does not have any left boundary, so we cannot store. Same for the right boundary. We have the left boundary but do not have the right boundary, so we cannot store any water here. So after here we cannot store any water because there are no left and right that closes it, means there are no left boundary and right boundary for this. It has right boundary this but does not have any left boundary. But for this, area it has a closing left boundary and it also have a closing right boundary. So the water can store here of the size of the left boundary, minimum size of the boundary. Here water cannot store because there are no right boundary and left boundary that closes it of its greater height. Here we have the left boundary and also right boundary, so water can trap here. No water can trap here. Here we have left boundary but does not have right boundary that is greater than this level. So no water can trap here. For this level it also have a greater left boundary and greater right boundary, so water can be trapped here. This here water cannot be trapped. So this is our problem. We have to solve this problem. So we will find that for every element what is the maximum left boundary and what is the max right boundary. So max left and max right. So what is the max left for each boundary, for this and what is the max right for the each boundary. So like for this, what is the max left? Max left is for 0, and for this max right is that is greater than this. Max right is here 1 2 3. So for this max right is 3. So if the height of this level is in between this, means it has a right boundary and a left boundary also, so water can be stored here. But height is 0, so what is the minimum? So minimum is 0, so height should be less than minimum. Means height is less than max left, max right, means it has a maximum left boundary that is greater than it and maximum right boundary that is greater than it, but height is 0, so there can no water store in this. Now so there is no water store in this. So at this level what is the max left? So max left for this level is 0, and max right for this level is what is the maximum right this side. So maximum right is 3. So what is the height of this? Height of this is 1. So what 1 is greater than 0 and 3. 1 should be less than 0 and 3. Means 1 should be less than maximum left and should be less than maximum right. So 1 does not satisfying the condition. So there will be no water store here. So no water. So our condition is that height should be less than minimum of max left or max right. Our height should be less than minimum of max left and max right. So means it can have a left boundary also and also have a right boundary. So for this it has height of 0 and what is its max left? Now max left is 1 because it has a right boundary maximum 1. So now our max left is 1. So now our max left is 1. And what is the max right? Max right is again 3. So max right is 3. So our height 0 lies, sorry, height is less than minimum of max left and max right. So max left is minimum 1 and height is 0. So it will be stored the value of what is the difference between this height and max length. So it will be stored 1. Same for this, what is the maximum left? Maximum left is 1 and maximum right is 3. But its current height is 2 and it is not satisfying this property. So there will be no water. At this point, what is the maximum left? For this point, maximum left become 2. So maximum left is 2 now. Maximum left is 2 and our current height is 1. So 1 is less than 2. Yes, it is less than 2. So how many water it can store? So 2 minus height. So 2 minus height is 1. So it can store 1 unit of water. And now for this, it is height 1. For this, it is height 0. And what is the maximum left? Maximum left is 2 and maximum right is 3. So is this satisfying the condition? Yes, it is satisfying the condition. So we will store the water 2 means 2 minus height of the current 0. Similarly for this maximum left is 2, maximum right is 3. So it can store 1 unit of water. For this, what is the maximum left? It has maximum left of 2, but it has maximum right of 2. You can see it has maximum right of 2. So maximum left of 2, but maximum right now became 2. So height 3 is greater than minimum of max left and max right. So there will be no water store. For this maximum left became 3. Maximum right is now 2 and current value is 2. So 2 is not less than, so it will issue 0 water. For this maximum left is 3 but maximum right is 2 and its current height is 1. So its current height is 1. So how much water will it store? So 2. What is the minimum between 3 and 2? 2 minus 1. So it will store 1 unit of water. Here it will store 0 unit of water. It is the boundary condition. So it will store 0 of water. So we have to find a maximum left for all the elements and we have to find maximum right for the all the element. So we will create a max left array and max right array for every element and equal to length of the height for every element. Then we will find the minimum height. So what will the minimum height? So for node we assume that for ith index we will find the max sorry minimum of max left and max right for the current index. Then we will find the minimum. Then if our this condition is satisfied, means height should be less than minimum, then we will store minimum minus height. Minimum minus height will be the number of storing units. So we will add into the our current storing. So let's see the code for this. First, I have checked that height is equal to null or height the l- length is equal to 0, means height is empty. We do not have any elements. So we cannot store any water. So we will return 0. Otherwise, we will store the length of the height into n variable and we will create a max left and max right for the each element. So we will create an array for each element of size n. So what we are gonna do, we are gonna like we are here. Let me explain to you how we are gonna find the maximum left and maximum right. So for the maximum left, we are gonna say that, hey, for this node, maximum left is similar to the left of maximum left. Means it does not have any left. So we will set it to 0. So for this, it will check what is the maximum left for this. It has maximum left of 1. For this, what is the maximum left? Sorry, this is also have maximum left of 0. It previous does not have any maximum left, so we will check what is the maximum between previous element max height and the current height. So that is maximum, so it has maximum height of 1. And for this, we will check what is the maximum height of the previous and current minimum. So minimum is 0, sorry, maximum minimum is 0, but we have to store maximum. So maximum is 1. For this, current is 2 and previous is 1. So maximum is 2. For this, 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 current is 3, but maximum left maximum is 2. So we will store the current maximum 3. For this 3. For this 3. For this 3. This in this way we store the maximum left for the each element and we have to do the same for the right element. So we will store back side, means for right element we have to what is the maximum right for this. Maximum right for this is 1 because because it does not have any previous element. And what is the maximum height for this? 1. For this, what is the maximum right and current height maximum? So maximum is 2. For this, maximum is 2. For this, maximum is 2. But for this, previous maximum was 2, but current maximum means current height is 3. So it will set the maximum right is 3. For this, for every 3, you can see it has the maximum 3. So for first, we will set max left of the height of 0, means we will set the what is the height of the first element. Then after that, for every element, we will iterate a loop for max equal to 0, I equal to 1. We will iterate a loop I less than 1. So we will set max left equal to max dot max. What is the max between? So current height and the previous element, means previous element max left. So what will the max will be set to the max left of I. For the max right, we will set n minus 1, means length minus 1 equal to height of n minus 1. So for this, it does not have any right element. So this height is already the max height. For other, we will iterate loop from n minus 2 to 0 and we will set max height for each element to the max height of its right element or max of current height. So what will be the max? It will set automatically. After this, the total water is set to 0 and we will iterate for I equal to for every element. We will check what is the mean height. So mean height for this is max. What is the minimum? I have already told you what is the minimum. So we will find max on max, max left and max right. So we will get minimum and we will store water that minimum height minus current height. So in this way we will store water. So and after that we return the total water. So be it 71%, quite a good solution. Thank you.